Hi students, in last class we have discussed about speed time graph, distance time graph, acceleration and velocity. Today we will discuss about the comparison of speed time graph and distance time graph. So topic is speed time graph versus distance time graph. First case is when a car is moving with uniform speed. Road is clear. Your car is moving with uniform speed. You are not increasing or decreasing the speed. There is no traffic on the road. So what will be the shape of speed time graph and distance time graph? We will discuss in this case when a car is moving with uniform speed. This is the speed time graph. So shape of speed time graph will be this. That line will be parallel to x-axis. For a moving body, its acceleration will be 0, since speed is not changing. And acceleration is the change in speed. Change in velocity is called acceleration. But when you see this case, suppose velocity is 2 meters per second. Time is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. There is no change in velocity. And basic definition of acceleration. When velocity changes, we have discussed in detail what is acceleration. There is no change in velocity, so acceleration will be 0. We will discuss the same case in distance time graph. When a car is in state of rest, then distance time graph will be same. Shape of both graph is same in speed time graph and distance time graph. But this is the case when the car is in state of rest. When the car is in state of rest or for stationary body. Suppose distance covered 10 meters, time is 1 second, 2 seconds, 3 seconds, 4 seconds. So there is no change in distance covered. In 1 second, body has covered 10 meters. 2 seconds, covered 10 meters. Body is in state of rest. So shape of both graph is same. But when we discuss this shape in speed time graph, then it is parallel to x-axis. And same graph when it is discussed in distance time graph, then it is for stationary body when the body is in state of rest. Next case, when a car is moving with increasing velocity uniform. Now you are moving with, you are increasing the speed of your car uniformly. Road is clear. So what will be the shape of velocity time graph? That will be the shape of this. Car is increasing velocity uniformly. So acceleration is constant. And this acceleration is positive. You are continuously changing the speed of your car. So acceleration is produced. When acceleration is produced? When a body is increasing speed, when a body is decreasing speed, when a body change its direction. So here it is continuously increasing speed. So acceleration will be constant. When a car is moving with uniform speed, velocity, in distance time graph is same. But in both cases, in velocity time graph, acceleration is constant. And in distance time graph, velocity is uniform and there is no acceleration. So in speed time graph, acceleration is constant. Acceleration is producing. It is positive. But the same graph, when it is discussed in distance time graph, then here acceleration is 0. Since there is no change in velocity. When you divide distance with time at every point, and we have discussed in detail distance time graph, and this line is obtained when a body is moving with uniform velocity, uniform speed. When there is no change in speed, then acceleration will be 0. In velocity time graph, acceleration is produced and that acceleration is constantly produced. That's mean, for example, acceleration is 2 meters per second in first case. Then at any time when you get the acceleration, then your answer will be, suppose velocity is 0. Here velocity is 2. And time taken, suppose this is 1 second. When you divide acceleration equal to delta V divided by delta T, this is the basic formula for acceleration. Delta V is 2 minus 0, change in velocity, and time is 1 minus 0. Acceleration is 2. You find acceleration at any other point. Suppose this is the point. Here velocity is 4. And time is, suppose 2 seconds. Change in velocity, 4 minus 2. Change in velocity, 4 minus 2. Change in time, 2 minus 1. Acceleration will be 2 meters per second square. So acceleration is produced and this acceleration is constant. But in distance time graph, speed is constant. Since speed is delta V equal to distance divided by time. So when you find speed at any instant, speed will be same. Suppose distance covered is 2 and time is 1 second. 2 divided by 1, speed is 2 meters per second. At any other point, suppose this is the point, distance is 4 meters and time is 2 seconds. 4 divided by 2, answer will be 2 meters per second. Since speed is not changing, speed is constant. When speed is constant, then acceleration will be 0 in this case. So in first case, acceleration is produced and that is constant. But in second case, acceleration will be 0 since velocity is same. Velocity is constant, acceleration is 0. Next, when velocity increases non-uniformly, velocity is increasing, speeding up a body, but it is not uniform. Some it is increasing speed more and sometimes it is increasing speed less. But speed is always constant, then velocity time graph will attain this shape. Increasing acceleration. Acceleration is produced, but at every instant, acceleration will be more. Same graph. In distance time graph, shape of graph is same, but it is for non-uniform motion when speed increases. Now speed is increasing. So distance time graph gives the velocity of the body. And this velocity is increasing at every instant. But when we discuss about in velocity time graph, then acceleration is produced at every instant and acceleration is increasing. Constant acceleration, when you find at every instant acceleration, in this case, suppose this is velocity, this is the time. Suppose velocity is 1 meter per second, velocity is suppose 2 meters per second, acceleration time is 2 seconds. When you find the acceleration, here acceleration will be change in velocity, delta V divided by delta T. Delta V is 2 minus 0, time is 2 minus 0, 2 minus 1. So acceleration is 2 meters per second square. We find the acceleration at any other point, that is 4. And time is suppose 3. So when you find the acceleration, change in velocity 4 minus 2, change in time, that is 3 minus 2, this is 2 divided by 1, it is 2 meters per second square. Take another point, Suppose this is the point. Time is 4. It is 6. Change in velocity. Body is speeding up, so velocity is changing. Four, 6, 8. So change in velocity is now 4 to 8. Change in velocity is 4. And change in time is 3 to 4, 1. So acceleration is 4 meters per second square. So acceleration is changing 2, then it is 4. Similarly, when you move up, it becomes 6, 8, 10. So in this case, acceleration is changing. But when you find the acceleration in this case, value of acceleration will be same at every instant. So in distance time graph, this graph shows the constant acceleration and this graph shows the increasing acceleration. Next, acceleration and deceleration. This is the comparison. When a speed is increasing, then shape of distance time graph will be in upward direction. When you draw the gradient, then this curve will be in upward direction. Similarly, when speed is decreasing, then shape of distance time graph will be this. That means curve is down the tangent. When you draw the tangent, this is the tangent. Curve is upward direction. But when you draw the tangent here, then curve is in downward direction. So this is for deceleration. When velocity decreases uniformly, this is the velocity which is decreasing uniformly. Suppose here velocity is 10. Time is suppose 8 seconds. Now at this point velocity is 8. Time is suppose 2 seconds. Velocity is decreasing. First is 10. Then it is 8, then velocity is 6, 4, so on. Velocity is decreasing. When velocity is decreasing, then acceleration is called deceleration or negative acceleration or retardation. So when velocity decreases uniformly, then speed time graph will attain this shape. And when velocity decreases uniformly, then distance time graph will attain this shape. Velocity is constantly decreasing. Here no acceleration is produced. When velocity is decreasing constantly, there is no change in velocity, then acceleration will be 0 in this case. Acceleration is 0. But here acceleration is produced which is negative. Negative acceleration is called deceleration. Suppose velocity changes from 10 to 8. First velocity was 10. Now it became 8. Acceleration is change in velocity divided by time. Change in velocity divided by change in time. This is called acceleration. So this is initial velocity, this is final velocity. 8 minus 10 divided by, this is the change in time. That was 8. And this was suppose 2. So initial time was 8 and final time is 2. Change in speed divided by change in time. So we will get minus 2. This is the initial, this is the final. 2 minus 8. Minus 2 divided by minus 6. It will be 0 point something. So when velocity is decreasing, then retardation is produced, which is negative acceleration, or it is also called deceleration. Next case, for non-uniform motion, when speed decreases or slowing down. Now speed is decreasing but it is not uniformly decreasing. This one. This is the graph for a body which is reducing its speed but non-uniformly. Then speed time graph will attain this shape. Similarly, for distance time graph, for non-uniform motion of a body when speed decreases. Speed is decreasing. Remember this, whenever you draw the tangent, then curve of the tangent is below. Whenever curve is below the tangent, this is the tangent, curve is below the tangent, then speed is decreasing. But this speed is not uniformly decreasing. But if the curve is in upward, above the tangent, then speed is increasing. So in distance time graph, speed is decreasing and acceleration will be uniform. But in speed time graph, velocity is decreasing and acceleration is not uniform. Acceleration is decreasing constantly in velocity time graph and acceleration is decreasing uniformly in speed time graph. This is the comparison between distance time graph and speed time graph. Now we will discuss the examination style questions. How questions are asked about this topic. Figure shows the distance time graph for three different objects A, B, C. These are the three different objects. Describe the motion of each object A, B, C by selecting the appropriate disk from the list below. Constant speed, increasing speed, decreasing speed, and stationary. So A, what is this? This is the distance time graph. This gives the speed. Since curve is above the tangent, if you draw the tangent here, and curve is above the tangent, so it is increasing speed. So A is increasing speed. B, this is the B, distance time graph. It is in the center, so it is constant velocity, constant speed. So this is the B, constant speed, B shows. Similarly, C, distance time graph, body is not covering a distance, so body is in state of rest, that means stationary. Remember this, whenever curve is above the tangent, and you draw the tangent, suppose this is tangent, and curve is above the tangent, then speed is increasing. If the curve is below the tangent, then speed is decreasing. Below the tangent, then speed is decreasing. Here, curve is above the tangent, so in first case, speed is increasing. In this case, it is parallel to x-axis, so body is in state of rest, and this is the constant speed. At every instant, when you find the distance and time, suppose 2, and this is 1. 2 divided by 1, distance divided by time, speed formula is distance divided by time. 2 divided by 1, your answer will be 1 meter per second. At any other point, this is 4. Time is suppose 2. Your answer will be 2 meter per second. That means speed is constant. At any other instant, 6, time is 6. Time is 3, distance is 6. 6 divided by 3, your answer will be 2 meter per second. So it is constant speed. And this is central, C, that is stationary. So this question is completed. Next. Figure shows speed time graph for 3 more objects D, E, F. Describe speed time graph now. Same objects, but now you have to discuss the speed time graph. First, D. This is your D. Since it is above the tangent, so it is increasing speed. When speed is increases, then acceleration is increases. Increasing acceleration. Since speed time graph gives the acceleration. Next is, it is in the center, so it is constant acceleration. So E is constant acceleration. And it is parallel to time axis. So body is moving with uniform speed. There is no change in speed. When there is no change in speed, then acceleration will be 0. But here, constant speed. Yes. This is correct. Constant speed. So this question is completed. Next. Parachute is used to slow down a certain racing car. Figure shows the racing car of total mass 750 kilograms slowing down by using a parachute. Figure 1.2 is speed time graph for 20 seconds after the car reaches full speed. This is the speed time graph for a car. So you have to tell the answers. Mark point A, where car is moving with constant speed. This is speed time graph. Which part shows the constant speed? This is the constant. It is parallel to time axis. Speed is not changing. Mark point B, where car is decreasing at constant rate. This is the decrease in constant rate. This point. This is B. C, mark a point C, where car is decreasing non-uniformly. This is the non-uniform motion. This one. This portion is C. Calculate the deceleration of the car at 6.5 second. This one is the 6.5 second. This is 7. And this is 6.5 second. You have to find the deceleration of the car at this point. Initial speed is 70. And this is 6.5. This one. And this point is 6.5. Here speed is this point. So 50 to 60, there are 5 lines. Each line shows 2 meters per second. So 1, 2, 2.5. So speed is 2.5 multiplied by 10. This is 52, 54, and 55. 55. This point, value of this point is 55 meters per second. And this is the initial VI, and this is final VF, and time is 6.5. You have to find the acceleration. So formula for deceleration is change in velocity divided by change in time. Change in velocity is 70 minus 55, and change in time is 6.5 minus 0. This is 15 divided by 6.5. You will divide it, and this will be your answer. Sorry, 55 minus 70, since it is decelerating. So it will be minus 15. Answer will be minus. Resultant force acting on the car at this time. Now you have to find the resultant force. Since mass is given, you will use the formula F is equal to ma. Mass is given 750, and minus 15 divided by 6.5. This will be your resultant force, which will be in Newton. You will calculate it. Explain why there is no resultant force acting on the car at time 4 seconds. First of all, you will check the 4 seconds. Where is 4 seconds? This is the 4 seconds. And this one, car is moving with uniform speed. When a body moves with uniform speed, then its resultant force which are acting on that car will be 0. So answer will be, as car is moving with uniform speed, so no resultant force acts on it. Therefore, it moves with uniform speed and acceleration will be 0. Since car is moving with uniform speed, when a body moves with uniform speed, then all forces acting on it will cancel each other. This will be your answer. All forces will cancel each other. That's enough. Or you can write, as the car is moving with uniform speed, so there is no resultant force acting on it. That's also correct.